I didn't know how to do that. I have a question, Kathy, we were talking about how do you add any wind in?
All right, so Lena, if you go into the chat, yes. Okay. If you go into the chat, are you able to see a live stream of my other computer monitor?
No, I just see like apps.
How do I go to the chat?
So in the upper right corner, you'll see like a little icon next to next to like the heads. You can see a little chat, and then
there's a link.
Yeah, a YouTube link. And click on that YouTube link. Maybe mute the video because it might have double sound going. I don't want that to cause feedback. But if the stream is working correctly, you should see an image of like my other screen. You see the middle of the screen?
Mm-hmm.
Okay, great. So Mateo, I think this is what I showed you on Friday of last week. I couldn't get my VR headset to stream correctly. So it's going to be using the regular interface here. But I just kind of wanted Elena to share like some of the ways that the Earth interacts with the Earth interacts with the sun and the moon to show what the phases look like. So what I'm going to do here is I have the Earth in the middle and then the moon orbiting around the Earth, and then I'm going to plop down a sun, which I'm just going to plop this down over here. It's a lot closer to the Earth than it would be in real life, but the simulation does a good job of at least, showing shadows and stuff being cast. So right now, let me set these to orbit correctly. Okay, actually I'm gonna delete that. I'm gonna place the moon in the correct spot. Orbit here. Okay, so you should see that here's the Earth. This is the side in the daytime. This is the side in the nighttime. It's the side that's facing away from the sun. And if you look at the moon, if I double click the moon, you should be able to see that regardless of where the Earth is, or regardless of where the moon is in relationship to the Earth, there's always going to be 50% of the moon illuminated by the sun at any one given time. Does that make sense? So even if I were to move the moon to a different location, say if I were to move the moon over here.
Hello?
Yeah.
For some reason, the audio and the graphics on my computer or my laptop are not working very well right now. And I can't hear anything you guys are saying.
Okay. That's weird. Well, just try to, use whatever device you're using right now. The audio is probably best if you have it come from the Google Meet. Yep.
Yeah.
So mute the video because there probably isn't any useful audio coming from the YouTube video. So just watch the YouTube video and then use the Meet audio to listen to what I'm saying. Does that make sense?
Yeah.
Okay.
The link isn't in the chat anymore. So I rejoined.
Repaste that. Okay.
Yeah.
Here, try that again.
Thank you.
Yeah, so what I was explaining was regardless of where the moon is I can have the moon be at anywhere relative to the Earth, and the same side of the moon is always going to be illuminated. It's always going to be 50%. The only way you'd ever have the moon 100% illuminated in light is if you were to have two suns, and have one sun on one side of the moon and then another sun on the other side of the moon. But since we only have one sun, only 50% of the moon is illuminated at a given time. But we can only see part of the moon because the moon changes its location every month. And when the moon is, say, directly in between the sun and the Earth, even though it's 50% illuminated on one side, we're only able to see the part that's illuminated on the back side. So this is what we call a new moon. Does that make sense? Just like nod your head if you can hear me. Great. So then, as the moon orbits around the Earth in a counterclockwise fashion, the light appears to be coming onto the moon. And it's not that it's going onto the moon more, it's just that due to parallax, we can see, only a portion of that 50%. So like if I look at the moon from above, that 50% hasn't changed of it being illuminated, but from our perspective here, this is just a sliver. And we call that the waxen crescent, because it's like a crescent, like half, like croissant shape. And the light goes onto the moon from right to left. Like if you've seen the Karate Kid movie and are familiar with like the wax on, wax off scene, I guess you could think of it as like most people are right-handed. When you apply wax onto, I guess in the movie he was waxing his car. When you wax something, put wax onto it with your right hand, the light goes on from right to left. And that's pretty much how the moon works. We wax the crescent onto the moon, and then as the moon orbits around the Earth, more and more of it get illuminated. And then here's like the point where we can see 50% of the moon illuminating or being illuminated, and that's called the, anybody remember what phase this is called, where the right side of the moon is illuminated? You can either shout that out or type it in the chat.
Waning gibbous? Is that what it was?
Right. So we're still at the beginning portion of the moon cycle where light is going on to the moon. So it's not waning yet. Waning is when darkness fills the moon. So we're still having light fill the moon. So it's not waning yet. But this is where 50% of the moon is illuminated, and it's on the right side. Lena, any ideas? It's if it's 50-50, that's considered a quarter. Because if I look at the sun, let me move the sun closer.
Oh yeah. Okay.
So if I take a look, the sun is on the right, the Earth is here, and then the moon is 1/4 of a way through its rotation. So we'd call this a quarter, and that's called the first quarter. So when the moon is 50% illuminated, we call that the quarter, and because it's the first quarter, that's just what we call it. And then as the moon orbits more, this is what we call a waxen gibbous, where it's the moon is like 3/4 of the way lit, but it's a gibbous where the light is still continuing to increase in proportion. So it's a waxing gibbous. We're putting more light onto the moon until we get to a full moon. And then when you're at this phase, the sun should be pretty close to being on the opposite side of the moon. So when you've got the moon on the opposite side of the Earth like this is a full moon. So we can see all 50% of the light from the top. Well, yeah, all 50% of the illuminated surface appears to us, which is what we would consider 100% illumination, because we won't be able to see the backside of the moon at all. Does that make sense? So even though it's a full moon, we're only seeing 50% of the moon total surface, because there's no way we can see all 360 degrees, because we can only see from one perspective. But then now that we're at the halfway point, as we go counterclockwise, we'll start seeing the light disappear. So as the light starts to disappear, we call that waning. So we would have a waning gibbous. So this next phase is when 3/4 of the Earth are still lit up by the moon. So like if I zoom in closer here, 3/4 of the light, 3/4 of the moon from our perspective are still visible. So that's a gibbous. But because the light is disappearing, that's waning. So it's a waning gibbous as opposed to a waxing gibbous. A waxing gibbous is where the light is, increasing in size, and waning is when it's decreasing in size. And then now, as I continue to go more and more counterclockwise, this is now where we're at when we observe the Earth from where it's 3/4 of the way through its full cycle, which is what we call the last quarter. And this is where the moon is illuminated 50% on the left instead of 50% on the right. And then we'll get into a waning crescent as we continue. So this is where it's a crescent shape, but it's a crescent on the left side of the moon, and it's a waning crescent because that light is disappearing. So waxing, so if you think wax on, that's the light growing. Waning is when the light is disappearing. And then it'll continue to wane, all the way until the moon gets back in between the Earth and the sun. And this is when we have a new moon. And then you'll notice with a new moon, it appears that no light is illuminating the sun, because all of the light that is illuminating the sun is facing away from the Earth. There's no way for us to see all of this brightness unless you were in a spacecraft on the other side. But because we're on this side of the planet, it appears dark. Does that make sense? Cool. So that's pretty much all I had to show with the simulation here. Hopefully that makes sense. Anybody have any questions?
No.
You, Mateo? No?
No.
Okay. Well, that's basically all I had to share. So, if you haven't had a chance to finish the Phases of the Moon activity on Schooloop yet, that's due tonight, or suggested to be due tonight. Otherwise, I think I'll